Solve Leetcode problem 2568, minimum impossible OR. We are given a zero index integer array nums, and we see that an integer x is expressible from nums if there exists some integers. So those integers are going to be 0 less than or equal to index I less than or equal to index 2. So there exist some integers, so for which all those with those index with the present of expression of OR, it's gonna equal to the x. In other words, an integer is expressible if it can be written as the bitwise OR of some subsequence of nums. We thus need to find the minimum positive non-zero integer that is not expressible from nums. You know, it's really difficult to understand. Actually, this problem. Actually, the meaning is that we're gonna check. Maybe you're gonna check the example, but the meaning for all those sentences is that we're gonna check from 1 to until maybe 10 to the power of 9. We're gonna check which number is not expressible. So for 1, we have one number, it is expressible. For 2, it is okay, and for 3, it is a 2 or 1. It is also 3, but for 4, it is not expressible. Normally, how can we solve the problem? Definitely, we cannot use the brute force because definitely it's gonna be time limit exceeded. So the idea is that we're gonna check the numbers one by one. If number 1 is not expressible in this example, we're gonna return this number 1. So for example, we have 2, 3, 5, so 1 is not expressible, so we're gonna directly return 1. Now we're gonna check the number 2. So in the first example, we have a number 2, so this means the number 2 is expressible. So for 1, we're gonna write it like this. For the binary representation, it's gonna be 0, 0, 1. So what about the number 2? We're gonna check number 2. So 2 is expressible because it is inside of the nums, so it's gonna be 1, 0, and here gonna be 0 and 0. Now if we have 1 and 2, now it seems that we're gonna have a 3. Normally, if we have a number like let's say, so if we have some number from 1 to 2 to the power of n, so basically by XOR operation, we're gonna have the numbers 2 to the power of n plus 1 minus 1, 2 to the power of n plus 1, 2 to the power of n plus 1 minus 1. Normally, if we have such kind of a range by XOR operation, we're going to have 2 to the power of n plus 1 to 2 to the power of n plus 1 minus 1. We're going to have this kind of formula. If you understand that, basically it's going to be an easy problem. Now, we have 2 to the power of n equal to 1, so this is a 2 to the power of 1. So this means we're going to have the numbers 2 to the power of n plus 1. It's going to mean 3. 2 to the power of n plus 1 minus 1. This is going to be a 3. So this means we're going to have after combination, we're gonna have a 3. So what is the 3? It is like this by XOR operation. Now, what is missing? Number 4 is missing, so we're gonna return a number 4. But what if a 4 is inside? What is gonna happen for us? So if number 4 is inside, we're gonna have here. But what about 5? Can we make a 5? Is that possible? Now we just need to check. Can we make a 5? Because 1 to 2 to the power of n, 1 to 4 is possible. So definitely means 5, 6, and 7 is possible according to the formula. Because n equal to 2, 1 to 4. So this is 5, and this is 8 minus 1. It's going to be 7. It means 5, 6, 7 is possible. So if we don't have 8, we're going to return 8. Otherwise, if we have 8, so we're going to have more numbers. It means from 9 to 15 we're going to have. We don't need to check that until we're going to check 16. So this means from the numbers 1, 2, 4, 8, normally we're going to just check all those numbers 1, 2, 4, 8, 16. If those numbers is not inside of the set, we're going to return on this number. So this is the minimum non-expressible number from the nums. Now let's just solve it. So we're going to prepare a set of nums and for I in reason, let's just say 32, because the maximum number is 10 to the power of 9, so 32 is enough. If 2 to the power of I not inside the set, we're gonna return 2 to the power of I. Yeah, so this is just the basic idea of how to solve the problem. As you can see, it's going to be really easy to code, but it's really difficult to think about it. And the time complexity is log n. N is this number, 10 to the power of 9. I think that's all about it. Thanks for watching. See you next time.